If you've just installed ANSYS and you have no idea where to start, this video is for you. In this tutorial, I'll walk you through your first ANSYS simulation step by step, from opening the software to turning and post-processing a complete analysis. We'll keep it simple, no advanced theory, no shortcuts, just exact workflow you need to understand how ANSYS actually works. By the end of this video, you'll be able to set up and run your own first simulation with confidence. Let's get started. Okay, the first thing we need to do is to open the ANSYS Workbench. And as so many of you commented for me before, you couldn't find the ANSYS Workbench. I'm going to show you the folder. So this is the ANSYS Workbench. If I right click on this and if I go to open file location, and if you have installed your ANSYS program in the default folder, it should be C program files ANSYS, and it goes all the way down to Windows 64. So this is the path, and if you run the Workbench or WB2, you would redirect it to this window. Here is where we select our analysis system. We have a bunch of different options like harmonic responses or LS-DYNA or static acoustic, static structural to steady state thermal. Let's say we want to have a static structural. We left click on it and we drag it and drop it here. This is going to be our project. We need to start with model name. This is the structural, static structural, so we can rename it as an example. For instance, example number 1. The first step is to select the materials properties. So if you have worked with Abacus, this engineering data would be equivalent to materials properties in Abacus. So we double click on this one. It brings us to another window. Here we are in engineering data sources. We have a bunch of different materials. If we want to hover around, as you can see here, we have general materials. We have gray cast iron, magnesium alloy, silicon, stainless steel, stuff like that. And you can create your own material properties as well. Let's go back here. If we want to create a new material, we can select here, we can input the name, and from here we can import the material properties, but we have to input them manually. I don't want to do that in this analysis. I would use a structural steel like this. We have density, we have fatigue parameters, as you see here is also mentioned. We have different options. So this is going to be our materials properties. And we close this one. As you see here, there's a check mark here. It means the material properties is done, and the next thing to do is to go for geometry. But before that, I'm going to select the unit. So if you go to unit system, you can select it from here. You have metric here, you have different options. So I'm selecting this one, metric, for this analysis, or you can select the default on SI and select this one for just this analysis, the metric. Okay, now you have to double click on the geometry and it redirects you to another software which is called ANSYS Discovery. It takes a while, and there we go. Basically what we have here is a modeling software under ANSYS. First we need to select the plane. By plane you can select a bunch of different planes. As you see here, I would like to select this one, which is the XY, and I always want to click on plan view so that I can create my model easier. Then I need to click on rectangle here, and you can select it here. I would like to put 100 for this one, and it is selected. So don't worry about the dimension. I'm going to reassign that here. So here we have this one, for instance. This is 8 millimeter. I click here, then double click and enter the value of 10. We can change the dimension really easy, like this one. And after that we click escape. It is done. Then we need to create the third dimension in the Z direction. So click on this pull. Then you can pull it, and you can either manually put it on 10, or before releasing the left click you can write a 10 and enter, and as you see it is created. This is pretty much everything in the modeling. You can create some other features, like for instance, if you want to apply the pressure in some part of this model, you can create a line, for instance, here on this one on the sketch, but I don't want to do that in this video because I want to keep things simple. We can either save the model or we can exit. If you want to save, just click on Ctrl S and save it in a document with a new design, or you can put a name for it like cantilever beam example and click on enter. But if you don't save the model and you exit the software, when you go to the model, it would be imported automatically. So as you see here, so far we have done the material properties, geometry, and we need to go to the model. So double click on the model. The good news is model would be our last stop, so we don't need to go through different software. But before we start, I want to ask you a favor. If you enjoyed this video so far, please drop a comment for me down below. It's totally free for you, but it helps me a lot to grow and create more videos like this. Thank you very much. We have the model imported here. In this model tree, we have everything like the model geometry, and if you have different sections, it would be here. We have material properties, we have the structural steel and things like that. But what we don't have here is mesh. So let's go and create a mesh. You can either click on generate mesh, or we can use face meshing, stuff like that. But I want to keep things simple, so we click on generate mesh here. And as you see, it creates a mesh. The mesh is not very good. And if you want to change the mesh size, one quick thing is to click on sizing. And as you see here, we have the sizing. First, we need to select geometry, as the color is orange for me. You might have selected a different theme for it. So if you click on this one, body, or Control B, you can select the whole model. And after you selected it, left click on here and click on apply until it turns purple. As it turns purple, it means it is selected. So here we have the element size. This is the default size. I don't want to have the default size. Let's have 2.5 E-3 and enter. If we go back to the mesh once more and we click on update, you would see that the mesh is updated. So this is a better mesh and the analysis would be more accurate. Mesh is also done. We need to go to the structural analysis settings, and it takes us to the environment. And here we need to select the loads and boundary conditions. So basically here we have the load, supports, fixed, displacement, things like that. And if we want to rotate it, we click and hold the scroll button and we can rotate it to go here. So click on fixed and select this face and click on apply until it turns purple. It means the fixed boundary condition is created, and I want to create a pressure on this surface. So I select this surface and let's have 5E7, which is 50 megapascal. Three faces must not be selected, so let's select only this one and click on apply. And yeah, the pressure is going to be applied only on the top surface. So far we have done the model, geometry, materials properties, meshing, and the boundary conditions and loading. And the last but not least is to go to the solution. But before running the job, we have to select the solution information. So here we need to select, for instance, deformation and select total deformation. Here, as you see here, is under the solution information. So basically we request them to be the outputs of this analysis. Let's say have maximum principal strain and equivalent 1 mesos stress and maximum principal stress. So we have everything. We can solve the model. So we go to the solution and click on this one, or you can press F5 and it is going to solve the model for you. Here, as you see, there's a bar. It's going to solve the model for you. You can pause it or you can stop the model if you want. All right, now the job is completed. Let's go to the total deformation, and here you can see the total deformation is 0.037 here. We're not looking to validate this one. It is just an example and it has educational purposes. And this is the maximum principal strain, elastic strain. Here we have equivalent stress, and this is the maximum principal stress. The value is pretty high, but as I said, we're not seeking to validate the model. And that's it. I hope you enjoyed this video. I'm going to upload more ANSYS videos like this, but in the meanwhile, click on the video on screen before it ends, and I see you there. Stay tuned.